Our planet is becoming increasingly unstable. Extreme weather events are happening more and more frequently on a worldwide scale. Scientists are in complete agreement. These are the early warning signs of climate change that threatens life on Earth.
Climate change is happening now. It's occurring both on a global and a local scale. It's happening at a significant level. The world has warmed by 0.7 degrees in the past century. Ireland is warming even faster than the rest of the world at the moment.
Irish investigators are thinking globally, but using local knowledge to chart a course for future generations.
We're really looking at what's the local angle, what's the local perspective on the bigger changes that are occurring across the globe that we have seen in the historical records and the likely future implications of that change for Ireland.
The signs are already here that climate change is upon us. By using the latest techniques in their cutting-edge research, Irish investigators are giving us a unique insight into the very real problems we will face in the future if we don't act now.
I think climate change has possibly replaced fear of nuclear annihilation in the consciousness of young people. My generation was brought up with a fear of the bomb, and now it's a fear of climate change. I think it's also important to realise that climate change is something that we can solve more easily. It's something that we can make a determined effort on today, which will give us options for the future. And it's not something which means we have to radically change our way of life to suffer sackcloth and ashes to solve. So I think it offers opportunities as well as threats.
Based in NUI Maynooth, John Sweeney and his colleague Rowan Feely have devoted their professional lives to studying climate change and how it affects Ireland, and in so doing are feeding vital information into the UN's global network. The International Panel on Climate Change is the conscience of the world, and you could say that John and Rowan have become Ireland's inner voice.
Well, the work that John Sweeney and Rowan Feely are doing is extremely important. The research that they are carrying out is really cutting edge. It's on par with what is being done by the best modelers in the world. And I believe that this work needs to be intensified and carried further, because the results that they would get from their research would be of great value to all of Ireland.
Even before humankind's influence, the Earth's climate has always been changing as it has adapted to the rise and fall of sea levels and to the planet's shifting land masses. In fact, Ireland owes its island identity to the last such major climatic event.
Well, although we're standing on the County Wexford coast today, the dynamic landscape of Ireland is such that that was not always the case. Out to sea here, it was in fact dry land, perhaps 5 or 6 miles out towards the peak of the last ice age, when sea level then was between 120 and 150 metres, probably lower than it is today, because so much of the world's water was locked up in ice. At that time, when all of that dry land existed, Ireland was probably joined onto Wales, probably joined onto parts of Scotland, and that created a very continental kind of climate. It was only as the climate warmed up and sea level rose that the submerging of land bridges created an island, created a maritime climate with which we are now very familiar in Ireland. Now, all of that happened in the past 8,000 years. That was the last major climatic change to affect Ireland. Now, of course, we stand on the verge of another major climatic change, a change which will be, in its own way, equally dramatic, because it will force us to adjust in how we organise society, where we plan to live, where we plan people and infrastructure for the years ahead.
Ireland is literally on the front line of the global effort to understand what is happening to our climate. And this is because of a unique weather station here on the windswept Atlantic coast of Connemara. Mace Head is one of the world's leading monitoring stations of climate change.
Mace Head is so special because of its location. Essentially, it's in the western part of Europe, where it receives very clean air from the Atlantic, and hence that's why a lot of European scientists are very interested in taking measurements there, and that we're the only marine background station in Europe. Yeah, here at Mace Head Atmospheric Research Station, we're looking at properties of the air, in particular aerosol particles, and these are particles which are suspended in the atmosphere, and we're also looking at gases.
The Mace Head measurements are fed directly into massive computers that can create a virtual reality of the planet's complex weather systems. This is known as the Global Climate Model, and it is the key to modern understanding of climate change. Mace Head has given us a treasure trove of information about the minute changes in air pollution that can build up to a global crisis.
The data is first of all stored in a computer here, and then it's distributed globally, and it's used by a lot of groups, including modelers. And for example, Dr. Stefan Kenna from the Max Planck Institute uses that data regularly to validate his models and to also serve as input to his models.
I'm interested in aerosol properties, and Mace Head provides a lot of interesting data, and we use these data in order to validate global models that eventually assess our current climate and also make prediction of future climates.
It's important to remember that while it's easy to start up a station, it's much more difficult to continue. And this is what we actually have achieved here at Mace Head. In fact, that we now have over 20 years of data, and that has been tremendous. It's allowed long-term trends to be analysed, and that's very important from a climatic point of view.
I think it's great that this site has been working for so many years, and that gives this data we measure now so much more value because we have a link to the past, basically.
The historical measurements from Mace Head are important because they can be fed into computer models that are then tested against the real climate conditions over many years. Once that climate model is verified, it can then be used to predict the future. But that's only the beginning of a complex story.
Global climate models only provides us information at a very large scale, and we have to find a way of bringing that down to a smaller scale which is useful for managers of environmental resources, for example. And we do this by a technique called downscaling. And downscaling involves telescoping down that big picture of the atmosphere, which may be the whole of Ireland in one case, down to perhaps Dublin or Cork or Limerick in another case, and we can then make decisions about how climate will change and the impacts it will have at those small scales as a result.
We're really looking at what's the local angle, what's the local perspective on the bigger changes that are occurring across the globe that we have seen in the historical records, and the likely future implications of that change for Ireland.
Rowan Feely travels the country gathering information and identifying where the effects of climate change will hit next. We will all be affected, and for some of us, it will be sooner rather than later.
Up until very recently, all we had to go on as scientists in order to look at the future changes were these large-scale global climate models. The predictions for the scale of Ireland are quite crude, one figure for Ireland on a daily basis, with no measure of the degree or the likely change in particular locations. Based on the modelling work we have undertaken, we're able to come right down the scale to a river catchment and almost look at daily flows. And from this, we can assess likely changes in future flood events. And this gives us a very critical information because it now means we can identify zones that are likely to be vulnerable in the future, areas that will have surpluses of water, and areas that are likely to be drought-ridden.
Under current climate conditions, there's a huge inequality in the distribution of available water resources in Ireland. In the west of Ireland, for example, there are about 76,000 litres of water available per person per day, whereas in the east and southeast, it's only 1/10 of that figure. There's no doubt that water is the central issue in any discussions of the effects of climate change. And on the East Coast, the issue has already become critical.
Dublin's been expanding for hundreds of years, and every now and again we've had to seek water. Pool of Fuca has been a fantastic resource, but just look at the scale of it, look at the size of it, and that isn't enough as it currently stands, and definitely isn't going to be enough as we row through the decades moving forward. And as a consequence, we're looking at either turning seawater into drinking water or tapping the Shannon. Either way, water is going to be the critical issue, and we're going to have to get it sorted, and get it sorted very quickly.
Climate change is going to exacerbate this major problem, which is why accurate climate modelling like Rowan's is all the more important.
The Shannon largely demarcates an area that we're likely to see the greatest changes occurring in rainfall for Ireland. To the west, we're going to see increases in rainfall in the order of about 20% by the end of the century. And this is quite a significant increase in rainfall, the knock-on effects of which we're likely to see in terms of an increase in the frequency of flooding and also in the size of those floods, how often and how big floods hit us on the west coast. What we've got to be aware of is that we've developed flood protection measures to protect us based on our past experiences of floods. However, this may no longer be a viable option because of the likely changes we're going to see arising from climate change.
At the other end of the spectrum then, if Wexford is the location really where we're seeing the greatest reductions in rainfall and also probably the greatest temperature increases. So that this is going to mean there's much less water available for drinking water, for other uses.
This is likely to create conflict for water users from agriculture who will require water for irrigation of crops, but also between industrial and commercial users and the domestic user.
Additionally, Wexford is a tourist town and this situation is going to be exacerbated in summer months. If you double the number of people in the town and you have the available water resources, you now have a situation, a conflict that will need to be resolved.
The computerised climate models also ring other alarm bells for Ireland. While the cities won't have enough water, the coastal plains are threatened with massive flooding, and the very coastline itself will be eaten away over time.
Well, our modelling shows that there are large parts of the Irish coastline which need special attention in the years ahead, because there are very large areas which may be subject to inundation as sea level rises and as wave energy increases. There are several 100,000 square kilometres which may be inundated at least once over the next 50 years. So this is Ballyconnegan, which is near Blackwater Harbour in County Wexford. In this case, we're looking at the problems related to sea and to sea level, and in particular where rising sea level and the increased energy which waves falling from a greater height will have on a soft coastline. And around us here you can see the sand and gravels left behind after the last ice age, which are being eroded by about a metre or so a year by the advancing sea. Behind me here you can see a crumbling house which has obviously not been able to withstand the wave attack of the past few years. And it brings to mind the need to plan for the future, because we are, after all, making infrastructural decisions today. We're planning where to build houses, planning where to build railway lines, and those are areas where we have to pay special attention to look at how well they're defended if necessary, because if there are people exposed, if there are houses exposed, then we have to look much more seriously at spending money to protect those.
As sea levels rise and climate patterns change, extreme events that used to happen once in a century are becoming more frequent. What disaster planners used to call a 50-year flood may now be happening once in every decade. County Louth farmer Eamon Toner has had first-hand experience of this trend.
Over the last 25 years, this land has been flooded on 2 different occasions. December '81, the tide just came in over the embankment, the ferry back. We all kind of got together and gathered up some money and got it repaired. So basically that was fine until then '02, it just was a freak wave or freak whatever, just came through again on us. In 2002 it came in through this breach here, and then it wasn't too bad for the first day or so, but then when the water come back out again, it took a bigger clipe out of it. So then that night to take him back in again, and it just kept getting bigger and bigger until we got it under control and got it closed up.
That's the embankment after the tide had taken it away. This is the next day, another tide coming in, and you can see how high up the water is there.
But it shows the way the tides
are
rising.
rising, absolutely, without a doubt, the tides are rising. Well, I never heard of it, and I'm living in this area all my life, and even older people that lived in the area before, we asked them after the flooding, and they couldn't remember any flooding here.
I never heard of it coming through before that, up in this last, twice in 25 years. So I think the pressure on the tides are rising, it seems to be just getting a bit higher. Well, you can see where the seawater lies. There's nothing grows in it for a long time after. You can see the hollows in the fields there, where there's really not any weeds growing in them. We did put crops in the years ago, but we're too afraid to crop it now, so we just use it for cattle. It's bad enough from the land point of view, but you see people that's built houses here up half a mile from here, and they're on the threat too. They can't walk away from their house.
While farmers like Eamon must look towards strengthening their flood defences, others further inland will also have to prepare for the effects of climate change. Rowan is using the computer models to predict the ways in which global warming might change Irish agriculture.
Nationally, tillage covers about 10% of the land area of Ireland. Much of it is concentrated in the south and east around the Wexford region. And with modest increases in temperature, we're likely to see a net benefit to tillage growth. This primarily comes about due to the enhancement from temperature changes directly, but also from the fertilisation effect of increased levels of atmospheric carbon dioxide. And these act as a fertilisation effect on plants, and they grow better. However, if these temperature increases exceed above a certain critical threshold, these positive benefits are likely to be negated. With the modelling system we employ, we're able to come right down to a field scale such as this and provide very detailed changes in future climate. And this allows farmers to make decisions that have a long-term impact, such as assessing their crop type. Is that likely going to grow and grow well in a future climate? If not, we now need to start looking at new crop types that we'll be able to derive much greater benefit from.
While it's clear that Irish agriculture will have to adapt to increasing climate change, what is less well known is how much it actually contributes to the problem. In other European countries, transport, industry and domestic use are the principal activities pumping greenhouse gases into the atmosphere. Here in Ireland, however, agriculture is actually the major source of greenhouse gas emissions. And Irish investigators like Padraig O'Keily are targeting some rather unusual suspects. The methane gas produced by cattle on Irish farms is equivalent to the carbon dioxide released by as many as 6 million cars. This is because methane is 25 times more powerful as a greenhouse gas. Irish investigators at Teagasc have set themselves an ambitious target to drastically reduce the amount of methane gas that is burped by the nation's 6 million cattle.
Our target is that we would reduce methane production from cattle by changing the diet by somewhere in the region of around 5 to 6%, which in another way of looking at it would be roughly the equivalent of maybe 250 to 300,000 fewer cars in the country. Where we are now is that we have 60 animals in here. They are in 5 groups of 12 animals. We'll have them here for about 120, 130 days, during which we measure how much they eat, how fast they grow, and in particular, how much methane that they will produce.
The key to this research project is diet. The methodology is to experiment with a selection of food mixes in order to identify which of these feeds produces the least amount of global warming methane.
This is maize silage, and you can see within this maize silage there's grain, there's leaf, and there's also stem. So quite different contrasting feed materials within it. And we have different mazes that have different amounts of those ingredients within them.
So the animals in here, they're on the 4 different diets, and when we take each animal out for sampling, we expect to see differences in the levels of emissions from the animals on the different feeds. sample the emissions, the animals are taken to another area of the research facility where they are kept for 5 days. On day 1, a halter is attached with pipes and filters. The gas which they breathe out through their nose is collected through this filter, passes up along the pipe and is collected in a PVC canister. The canister is changed every day and a sample of the gas in the canister is taken in the lab for analysis.
Just as the climate researchers built computer models to study the planet, Padraig O'Keily and his team have built a laboratory model to study the workings of a cow's stomach. The basic principles of scientific investigation are the same.
I suppose for an investigator, the exciting thing is that you're looking into the unknown and you're saying that there is potentially a huge jigsaw of information here. What will be critical firstly is to get the big picture right and then to start filling in all of the pieces. So this is a simulation of what's happening in the cow or bullock's stomach. You have 8 vessels, each of which replicates the stomach of a cow or a bullock. And over time, it is doing exactly the same as is happening in the animal's stomach. And we will firstly verify that the results we're getting from this are exactly the same as we were getting from the animals. And then once we've done that, we can then use this system to screen an array of other feedstuffs, many more than we could easily feed to animals, to see are they prone to producing a lot of methane or very little methane. What's really exciting is that we now have we will have a sequence of information going from the live animal and its stomach through this system here. We can follow it right down through the microbiology, down to the cellular level, down to the genome level. 2 things we will learn. One is how much methane is produced on the different feeds, but in some ways even more importantly, how it is being produced. What is the actual microbiology that's happening in there? What bacteria are functioning and how are they functioning? Because if we understand that, then we have the wherewithal to create conditions in the rumen to prevent those type of bacteria dominating and producing methane or much methane in future.
From studying the lowliest bacteria in the stomach of a cow to the awesome complexity of our global warming models, investigators in climate change are getting a clearer picture of how we in Ireland can adapt to the changing world around us.
We have, I think, for the first time, the tools at our disposal to answer many of the questions which have eluded us about climate change, many of the what-if questions. What if we double CO2? What if the sea levels rise? And for the first time, really, we have the computing power and the models available to give us insight into answering those questions. And it means that we can then start saying to people in authority, to decision makers, here are your options for the future.
Operators at Mace Head are already seeing what can happen when investigators' evidence is acted upon. 30 years after the first warnings about an ozone hole in the atmosphere, harmful gas concentrations have begun to fall.
You can make a difference. Because I can see the effect of the control mechanisms, and I see them directly because I'm making the measurements all the time, I know that something can be done about climate change. The drop-off in the concentration of the CFCs, the gas species that were controlled by the Montreal Protocol, they're all dropping down now. So, I mean, that's a very positive result. I mean, it tells us, you know, if you stop people producing stuff, you will have an effect.
The information gathered by Irish investigators is irrefutable. It's now our responsibility to act on it.
Climate change and climate are really central to the whole debate. They link river flow, they link ecosystems and habitats, and they link the weather above us into this comprehensive system. And the key questions I'm really asking myself here are we prepared to lose this? And certainly the answer I'm coming up with is no.
The problem with climate change is in the sense that we are compromising the future to continue our present-day lifestyles too much. And in so doing, we're restricting the choices for the people that we leave behind at the end of this century. And I think from a moral and from an ethical point of view, that's not really defensible.
Thank you.